Well, welcome back, men. Today we're going to be talking about areas of triangles using trigonometry, and then we're going to get into areas of segments. So suppose you want to find the area of triangle ABC. So have triangle A, B, C, but you only know the lengths of side B and of side C. You also know the measure of angle A. To use the formula area equals 1/2 base times height, you need to know the height, h. And you could draw in any segment perpendicular to find this height. So in order to find this height, how did we find the height in the past? Well, we looked here. We said I need h and I know b. So we would say that the sine of A is equal to h over b. And solving for letter h, we would cross multiply, and we would get that h is equal to b times the sine of angle A. So if I was to substitute this into the area is equal to 1/2 base times height formula, I know that area is 1/2 times letter C times B times the sine of angle A. And what we just found is the area of a triangle given side angle side. So just depending on what you have, if you have a triangle here, any two sides in the included angle, then you could use this formula. That's 1/2 times, I'm going to call it A times B times the sine of angle C. So if you take a look, I've got a side, I have a side, and I'll have the included angle. Or you could say B, C, and the sine of angle A divided by 2. Or you could say C times A times the sine of angle B divided by 2. All of these are formulas that work for the area of a triangle. So let's take a look at example number 1. I have 5, I have 7, I have 49 degrees. So we would say area is 1/2 times 5 times 7 times the sine of 49. And we knew that 5 times 7 is 35. So area is 35 sine of 49 divided by 2. Now I didn't tell you what to round to, but let's just say they asked me to round to the nearest tenth. So then you get your calculator out, you say that the area of the triangle is 35 sine of 49, and you divide that by 2. And I said round to the nearest tenth, we get 13.2 units squared. Looking at our second example here, I got area is equal to, and we'd say 1/2 times 2.6 times 6.9 times the sine of 117 degrees. So there's a lot of decimals here. We're going to round this to the nearest tenth. 2.6 times 6.9. So area is equal to, and I got 1/2 times 17.94 times the sine of 117 degrees. So we're going to take and divide that by 2, and then times that by the sine of 117, rounding that to the nearest tenth. Well, this is about 7.99, so we say area is 8 units squared. This section is going to be focusing on segments of a circle. We've all been to Mr. Gaddyland, or maybe you have. I don't want to assume that we've all been there, but we've gone, and if you've seen it and you see the little cinnamon sticks that they have, or the cinnamon type pizza, and they're cut like this, all right? And that little piece right here at the end is what we call a segment of a circle. It's a part of a circle bounded by an arc, and the segment joining its endpoints is this segment of a circle. So what we're going to do is we're going to find the area of the segment. But the area of the segment follows this procedure. We've already spent time talking about how we find the area of this sector. So if I was to call this sector A, B, then I need to find the measure of that arc AB. And the measure of that arc is the measure of this central angle. So whatever that central angle is right here, that is the measure of my arc, or vice versa. So I'm going to take the measure of that arc, divide it by 360, and times it by the area of a circle, pi times radius squared. Now if I wanted to find the area of my triangle, we knew that this is a radius and this is a radius. Well, we just spent time talking about how we find the area of a triangle using side, angle, side. So this arc right here is the same as that of arc AB. That central angle is this same arc. So again, what we're going to need to do is we're going to have to use that area formula. But instead of having two different side lengths, it's r times r, which we're going to call r squared. So the area of a triangle inside of a circle is 1/2 times r squared times the sine of arc AB. So again, we're going to have to do the area of the sector minus the area of my triangle. So we are asked, what is the area of the shaded segment right here? And we are to round our answer to the nearest tenth. So I have a 60-degree central angle. So if my central angle is 60 degrees, I know that arc AB is 60 degrees. So I'm going to do 60 over 360 times, our radius here is 18, so 18 squared times pi, can't forget my pi, minus 1/2 times 18 squared times the sine of the arc, so times the sine of 60. And simplifying right here without the pi, I get 54 pi minus 1/2 of 18 squared, so 18 squared is 324. 324 divided by 2 is 162. So I get 162 sine of 60. So I just wanted you guys to see what we could do here. That would be my exact answer. So now 54 pi minus 162 sine of 60 to the nearest tenth. I get